Okay, now let's do a practice for chapter 13. We're going to look at a adjusted winner procedure, and we're also going to look at master inheritance. So in the first example, we have Tom and Sandy making fair division of 3 objects left by their great aunt Sally, and they've assigned points below. The first thing that you want to be sure of when you do a problem like this, and I want to use this one because I have a little more room underneath it. When you do a problem like this, is to make sure that these totals add up to be 100, and they do. Okay, so we're just making sure that they used all the 100 points. The next thing that we do is go through and we temporarily assign the highest total to each person for each item. Now again, it's a temporary assignment because the next thing is we're going to add up those points that they were awarded and see if they're equal. And obviously here 90 is not equal 50, so that's just not going to work. So now I need to find out what my point ratio is of the person that has the highest amount of points, their points over the person with the lower points. So I have 40 over 30, which is 1.3 repeating, and I have 50 over 20, which is 2.5. So this is my lower point ratio. This is the one that I'm going to be splitting up. So I'm going to take one of these and multiply it by x, and the other one and multiply it by 1 minus x. Also, when I'm doing my equation, I don't want to include the 40 anymore into the 90 because I'm going to be splitting this up. So it's not going to be all of 40. So I have to take that 40 away and make this side 50 as well. Now I'm going to do my variable on both sides problem. I'm going to come over here and I have 50 plus 40x equals 50 on this side plus 30 times 1 minus x. So I'm going to go ahead and simplify this equation here, and I distribute my 30 through. So I have 30 minus 30x. And then over here I have 50 plus 40x. So this is now 80. And once I get to this point, I have my variables still on both sides, so I want to take my x on one side and take my number on the other. So I'm going to add 30x to both sides. I get 70x equals, and then I subtract 50 from both sides to combine my constants, and I have 30. Continue to solve this equation by dividing by 70, and x will equal 3/7. Now we talked about before how this is kind of looked at as a percentage. So I'm going to take 3 divided by 7 and find out that this is about 43%. My other person, the x will go with Tom. So this is Tom. Tom has 3/7, and then Sandy is going to have the remainder of 7/7, which is 4/7. So if I also want to take a look at what percentage 4/7 is, that would be 57%, and it should be because these two should add up to be 100. Okay, so far what do we have? We want to see who gets what items. Tom will get the car, and he will get 3/7 of the painting. Now if you put here 43%, I would accept that as well. Sandy gets the jewelry, and she gets 4/7 of the painting. And you might say, how does that work? How does somebody get a portion of the painting? Well, what would happen more than likely is one would buy the other one out according to its value. So Sandy might pay 43% of the value to buy it from Tom, or Tom might pay 57% of the value to buy it from Sandy. Now the last thing we need to do is make sure we have our point ratios the same. And in order to do that, I have to take these fractions and get my number amounts. So I'm going to have 3/7 times 40, and I'm going to have 4/7 times 30. Okay, and I know that's an awful lot of stuff that's all crammed together up there. Let's take 3 divided by 7 and multiply that by 40, and that'll give me my number. So 17.17. So instead of adding 40 below, we're going to add 17 point, oh, not 14. Okay, so that gives me a grand total over here of 67 and 1400ths. Now on the other side, I'm going to take the 4/7 and I'm going to multiply it by 30, and I also get 17.14, which is a good thing, because now when I add them together, I see that these are both the same. And that's what I want. So using the adjusted winner procedure above, how many points of value do they end up with? That answer is 67.14. Okay? All right, now number 4 is a Naster inheritance. So we have Andy, Chris, and Kim have to make a fair division of a car left to them by their father. Using the Naster inheritance procedure, what values they bid on their car given below. Find the results. Okay, so the first thing, none of these know what the other person bid. We see that the highest bid was Chris. So Chris is going to get the car. Now there are 3 people involved. So Chris is going to have to put 2/3 of his 3,000 into the kitty. And the reason that it's 2/3, once you take him out of the equation, that's still 2 out of 3 people left. So when I multiply 3,000 by 2/3, you see the 3 will reduce into the 3, and I get 2,000. That's going to go in my kitty over here on the side. That's my temporary storage place for my money. Now, the other people, since there are 3, they get 1/3 of what they bid. So you're going to divide this by 3 and get 800. And that means that Andy will get 800. After Andy gets 800, we want to take a look at Kim, who has 2,700, and we divide that by 3, and she will get 900. And there's 300 left in the kitty. So what happens to that 300 is it actually gets divided by 3 because it goes to all 3 people. So each person will get $100 more. So instead of, over here we had Andy getting $800, Andy's going to get 800 plus 100, so he's going to get $900. And instead of Kim getting $900, we're going to add $100 more to her, and she is going to get $1,000. Now the last thing that we might want to put down here, and it isn't asked specifically, but we want to show, it does say find the results. So the results of the fair division would be Chris getting the car. Now Chris got the car, had to put $2,000 in the kitty, but got $100 back. So he actually had to pay $1,900 to get the car. Andy ended up getting $900. And finally Kim gets $1,000. And that would be the final results for the Naster inheritance problem.